Hello, my name is Ramasu, and welcome to my presentation on question 1 to 5 from the 2013 GCSE Science Double Award Paper 1. The question reads, the diagram shows a boy sliding down a slope. In which direction does his weight act? Well, his weight will act in the direction of C. Right, in this direction here. What is happening to my pen? C. Right? Because well, if you have an object, the weight will always act downwards to the ground. Right? But question 2 says the diagram shows a child of mass 30 kilograms on a seesaw. At which position should another child having twice his much sit so that the seesaw is balanced? Well, this uses the principle of moments. The principle of moments. This question is about the principle of moments, which states that the sum of the clockwise moments about a pivot should be, or not should be, but is equal to the sum of the anti-clockwise moments about the same pivot, for a balanced system. Right? So for the seesaw to be balanced, the sum of the clockwise moments should be equal to the sum of the anti-clockwise moments, right, about a certain pivot. So if this seesaw is to be level like this, the sum of the clockwise and if this is the pivot, the sum of the clockwise moments about this pivot here should be equal to the sum of the anti-clockwise moments above the same pivot. So if this child has a mass of 30 kilograms and is sitting at this point, a child of mass 60 kilograms should sit closer to the pivot if the seesaw is to be balanced. This simulation will help to explain what I meant. So here we have a child of mass 30 kilograms, right? So we placed the child there. So then we can see that her weight is pointing downwards. Now if we place someone of mass 60 kilograms, let's put this person at the furthest end of the seesaw. You see how the seesaw becomes tipped. Well, these people, well, this person has a mass of 30 kilograms and this one has a mass of 60 kilograms, and they are the same distance from the pivot, yeah, right? So the pivot will be tipped in the 60 kg person's side, because this person has a larger moment about the pivot than this 30 kg person here. Now if we move this person closer to the pivot, okay, let's move him. If we move this person closer, the seesaw is still tilted to their side. Now let's move them even closer. If we move this person too close, then the seesaw will be tilted in the 30 kg child's side, because this child now has a larger moment than this person here. Now if we put this person at the right distance, the seesaw becomes balanced, because these people have the same moment. So this is where the principle of moments comes from. So for a balanced system, the clockwise moment about a certain pivot should be equal to the anti-clockwise moments about the same pivot. Okay, our answer here should be B. Question 3 says a brick of mass 2 kilograms falls from a floor which is 4 meters high. What is the kinetic energy of the brick when it touches the ground? So in this case, we have to assume that because the brick was high, it had potential energy. But we have to assume that all this potential energy is converted to kinetic energy, right? To kinetic energy. So there are no loss. So then we can use the formula for potential energy, which is P is equal to mass times gravitational pull times height, right? Our mass is 2.0 kilograms, our G is 10, and our height is 4 meters, right? And this gives us 20 times 4, which gives us 80 joules, right? Then our answer there is 80 joules. 4 says which source of energy causes air pollution when it is used to generate electricity? Well, coal will cause air pollution because you burn it to release carbon dioxide, sometimes carbon monoxide, and sometimes sulfur dioxide, if the coal is not pure, right? And all these gases are pollutants. Question 5 says which setup is suitable for determining the upper fixed point of a thermometer? We can cancel out B and D, because the thermometer is supposed to be placed above the liquid. It shouldn't be like in direct contact with the walls of the flask there. So then our answer would be C, right? So that is the end of the video. My name is Ramasu. You can find me on Facebook, or you can follow my Facebook page, GCSE tutorial videos. Thank you for watching, and see you in the next video.